Welcome everyone to another video in which we are going to solve problem number 11 from chapter of force vectors, which is second chapter of engineering mechanics book by R.C. Hibbeler. In this problem we are being asked to determine the resultant force and its direction, which is measured clockwise from the horizontal. So this is the body at which there are two forces acting at point A and at point B. Their magnitudes are given and also their direction is given. So let's solve this problem. Let's first solve for the magnitude of the resultant force. For the magnitude of the resultant force, we are going to use cosine law. So if you remember, the resultant of two forces by cosine law is calculated by this formula. In this formula, Fa and Fb are the magnitude of Fa and Fb forces. The alpha angle is the angle between these two forces. We are not directly being given with the angle between Fa and Fb, but we can determine the angle between them. This theta is given, which is 60 degree. So 40 and 60 will make it 100, and you know that the total angle from positive y-axis to the negative y-axis is 180. So subtracting 100 from 180, we will be left with 80 degrees. So this angle, the angle between FA and FB, is actually 80 degrees. Now simply putting the value of magnitude of Fa, Fb and alpha angle, we are going to get the resultant force. So let me put it. Fa is 8 kilonewton, Fb is 6 kilonewton, angle alpha is 80. So on solving, we are going to get the resultant force of these two forces as 10.13 kilonewton. So this is one of the answer which was being asked to us. Moving on for the direction of the resultant force. First of all, we have to show the direction of the resultant force hypothetically. Since this angle is 60 and this angle is 40, so this is less. However, the magnitude of Fa force is 8 kilonewton higher than Fb force, but due to the angle which is quite low in case of Fb, so as a result of that, the resultant force will be more towards this side rather than this side. Now we will apply sine law to determine the direction of the resultant force. Now according to sine law, we need to draw the triangle first, and then using the magnitude of the forces and the internal angle in that triangle, we can determine the direction of the resultant force. Let's see how. Let me transform the Fa force from here to here. Now in order to form the triangle, we need to put the tail of the second force at the head of the first force, like this way. Now the closing side, means from start to the end, will be then the resultant, means this side. So now we have the triangle. In this triangle, we should be knowing with some internal angles. Let's see how. We know that this Fa force makes an angle of 60 degree with the vertical, and this Fp force makes an angle of 40 degree with the vertical. So if this is 60 and we have these two dotted parallel lines, the vertical lines, and that Fa force is crossing them. If this angle is 60 degree, then this angle will also be 60 degree. So as a result of that, this internal angle would be 40 plus 60, it means 100 degree, but we are not sure with this angle. Let's name that angle as beta. Now according to sine law, since we are interested in beta angle, so we'll write as sine beta. This should be divided with the magnitude of the opposite force. In this case is 6 kilonewton Fp force. Now sine of the other angle which should be known, this angle we are not being known to this, so we are not going to use this angle, but this is the only angle which we know, that is 100 degree. So this should be divided with the magnitude of the opposite force, and in this case is Fr, which we just have calculated, that was 10.13 10.13. So in this equation, we can solve for beta angle, and on doing calculations, we are going to get beta angle as 35.65 degrees. I believe you understand how I did it. First of all, I shift this 6 on the other side, and then I determine the inverse of beta. So now we have this internal angle of 35.65 degrees, but this is not being asked to us. We are being asked to determine the direction of the resultant force, which is measured clockwise from the horizontal, means this force was required. So if I mark the horizontal here, if this angle is 60, so this will be 30 in order to make 90 between horizontal and vertical. So if we want this angle, then simply we subtract 30 degrees from 35.65. So when we simply do that, then we are going to get the angle as 5.65 degrees. So now we got both the answers. The magnitude of the resultant force we just determined as 10.13 kilonewton, and the direction, which was measured clockwise from the horizontal, which we determined just now, is 5.65 degrees. So that's all, I think. So this is all from this video. Thank you for watching this video where we have calculated the magnitude of the resultant force and also its direction measured clockwise from the horizontal. I hope I tried to make it as simple as possible, but obviously there would be some doubts. If you have, then please let me know through the comment section so that I can get back to you. That's all from my side. Thank you for watching this video. I hope to see you in next coming videos. Till then, bye.